So a special request from Celeste to talk about molten iron rain falling through the skies of scorching hot exoplanet. And this is really cool. I like this idea a lot. I like the idea of molten iron rain. Pretty amazing. This article is from space.com. I'll read some things out to you. It says here, there's a new contender for the most exotic exoplanet. Title: The crown may have rested for a while now on the head of HD 189733 Bravo, a cobalt blue alien world where molten glass rain whips sideways through the air at around 5,400 miles an hour. So what is that? If it were the speed of sound is like around 720, what would that be? 9 times the speed of sound? But a new study reports that iron rain likely falls through the thick, turbulent air of WASP-76 Bravo, a bizarre, ultra-hot Jupiter that lies around 640 light-years from the Sun in the constellation Pisces. WASP-76b whips around its host star once every 1.3 Earth days, an orbit so tight that when the gaseous planet, what they say is tidally locked, always showing the star the same face, like the moon always shows the same face to the Earth. But I don't think that's true. They say it's tidally locked based off of certain assumptions, but I'll explain why that isn't true in a second. Temperatures on the day side climb to around 4350 degrees Fahrenheit, which is 2400 degrees Celsius, hot enough to vaporize metals, where the night side is a much cooler, but still ridiculous 2730 Fahrenheit, 1500 Celsius, researchers said. To reference the tidally locked aspect of it, or their claim of tidal locking, what is interesting to note is in the same article, they say here, the best explanation he has that the winds and WASP-76 Bravo's rotation carry vaporized iron from the day side to the night side. They just contradict themselves in their article. Clearly, the object is not tidally locked. It rotates, just like Jupiter does. Of course, the rotation is a bit slower. It rotates at around 18,000 kilometers an hour. So imagine you're standing, if it had a surface, it's not a gas giant, imagine you're standing on the surface of it. You're going laterally, think of like a basketball spinning. You're on the basketball's edge and it's spinning. You're going the direction it's spinning at around, 18,000 kilometers an hour. And in comparison, Jupiter's rotational velocity, or surface velocity, is 45,000 kilometers an hour. Now, for those that want to put that in perspective, the speed of a rifle round is around 2,000 to 4,500 kilometers an hour. So the surface of this iron world is spinning around between 9 times, or what would that be? 4 to 9 times faster than a bullet coming out of a rifle, which is really fast. But for something so big, if you were to look at it, it would just look like it's staying still. Like if you watch clouds, a lot of clouds, they look like they're staying still. But if you do a time lapse on them, they're just like flying. Same difference. I mean, I'm sure if you were to be trying to skydive in the atmosphere, you wouldn't have a good time. But yeah, iron rain, of course, is expected inside of the medium-aged exoplanets. I say medium-aged exoplanets because the iron rain one that they found sits right above Jupiter. It's a little bit, I think it's a little bit heavier than Jupiter, if I'm not mistaken, and it's a little bit wider. But it was a brown dwarf in its previous stages, and of course it was a red dwarf earlier. And Well, it's continually evolving, and we see the process happening. A lot of the iron is being excavated through the atmosphere and ripped away, and it's being removed from the object. So I guess the iron core won't have a lot of material to form out of because it's being ripped off of it. But I mean, yeah, the iron rain's still there. It's really, really hot. And to correct them, they say it's the most exotic exoplanet. No, not even close. The astronomers sort of have this strange worldview that exoplanets and stars are exotic, not realizing that what that means is that they don't understand that the evolutionary process of a star is what creates life itself. So if they want to talk about exotic, well, it's the stars that host life. We're exotic. We're incredibly complex, vastly complex. Biological organisms are directly a cause of a star's evolutionary history. It's a star that creates life over many billions of years of its evolution when it mixes all those materials together. So that just shows you where their mind is. They think exotic, meaning it's different in a kind of mechanical way. But if they understood that stars create life, then they would realize that it's a bland world. It's not exotic at all. It's a world at intermediate stages that just is doing its own thing, and eventually it's going to become exotic as the elements combine together to make more and more complex molecules and things like that. And I just wanted to correct that as well here. You can also tell where the astronomers' minds are. They say here, Ehrenreich. I don't know how to pronounce that name. Ehrenreich. It says here, quote, "We have to stretch our understanding of what is a climate, what is a planetary atmosphere, to understand this object." Well, in order to understand what is a climate, you first have to understand what the Earth actually is, because we look at Earth as being sort of a human-centered thing. Like the climate, is, it gets cold at night and then it gets hot during the day, and there's rain and there's sometimes snow, and it's, hospitable to us. So we're like, we set our mind to like, oh, this is the climate. And I wrote this in a previous paper back in 2016, that the climate of a star is incredibly different the younger and younger it is. The more energetic it becomes, the younger it gets. So, and we can see that this is intermediate age object because it has iron that can condense into vapor. But if it were an actual much younger star, that iron wouldn't be a vapor. It would be a plasma. And a plasma is completely ionized to where it shines like the sun. So if you scoot this WASP-76b object back into its past, you'll find out that its so-called climate was actually, the entire atmosphere was enormously thick and ionized, completely ionized into a plasma. And the further and further you go back, the more plasmatic it was, the more energetic it was, the more different it was, to the point where astronomers still call them as being an independent object. They call the young exoplanets stars still. And to me, it gets weirder and weirder as we go, but I'm sure as long as they sort of question how they define simple things like climate and what a planetary atmosphere is, if they sort of question that, I think they're on the right track. Because over the past 50 years plus, they never really questioned it. They just sort of looked at Earth as being, oh, well, this is a climate, and this is what we can expect to see. And they sort of made their assumptions true long before they had all the information available to actually make an accurate assessment. So now that they're finding these exoplanets and they're getting more accurate numbers and they're getting more accurate statistical data, meaning they're actually finding objects that are different stages of evolution. They're actually looking at them and studying them. They're going to change tune. They're actually going to look at their assumptions now, and they're going to be like, well, maybe we really didn't have it all figured out, and That's what I've been saying this entire time. They don't have any idea what they're talking about when it comes to planet formation and star evolution, being that it is the exact same process. And one day they'll realize it, and they'll see that this WASP-76b is a intermediate stage. It's a young Earth. Over time, all that iron rain is going to sink into the center and collect in the center and form the core. It's pretty simple to understand. The iron that doesn't collect in the center is going to mix with the other elements and create things that we find on the surface of the crust of the Earth. So the crust of the Earth is iron ore. And iron ore combines with oxygen. Iron ore is with other elements too, such as magnesium, calcium, and it forms various rocks and minerals that we find on the Earth. See, this iron rain isn't as exotic as you think it is. The Earth had iron rain in its past as well, just like WASP-76 Bravo did. The Earth was exactly like this object, almost spitting image. So if we want to understand what the Earth was like, I would say this object is around between 400 and 700 million years old, similar to Jupiter and Saturn. If they want to understand what Earth is, when Earth was a gas giant in orbit, really close orbit around another hotter host object, well then there you go. You're studying it. You're observing it. It's pretty cool. You can look at the past of the Earth, what the Earth was like. But I don't know if they're going to figure it out. I don't know if they're going to figure out that that's the young Earth. Maybe the more intelligent of the ones will figure it out, and of course, they're going to be quiet about it. They're not going to speak up and tell their colleagues. They're going to shh. Don't want to be blacklisted from the journals. Don't want to have people looking at me and calling me a pseudoscientist or whatever, because that's what academics do. They ridicule each other viciously, and they're very nasty to one another. So it helps to just be hush hush about it. But secretly, I think a lot of them know better. All right, guys. I think I made this talk long enough. I forgot to say hi, Celeste. Later.